Hello students, I am Subhashish. In this lesson about algebra, we explore the topic of pair of linear equations in two variables, focusing on the graphical method for solving these equations. We'll understand the basics of linear equations, their graphical representation, and how to determine their solutions. The lesson also covers different types of solutions and provides examples and exercises to practice graphical solving techniques. Let us see the learning outcomes that we can learn after the completion of this session. Learning objectives. After completion of this session, you will be able to plot points on the graph for a pair of linear equations in two variables, use the equation to predict x and y values, to solve various problems using two variables where one is known and other is unknown. Keywords: equations, variables, coefficients, graphical method, linear equations, intersecting lines, coincident lines, parallel lines. In our previous classes, we have learnt about the linear equations in one variable and linear equations in two variables. Let us recall some points from our previous classes. An equation is said to be a linear equation in two variables if it is written in the form ax plus by plus c is equal to 0, where a, b, c are real numbers and the coefficients of x and y, that is a and b, are not equal to 0. Let us see the graphical representation of linear equations in two variables. Linear equation. A linear equation is an equation of the straight line. It is in the form of ax plus by plus c is equal to 0, where a, b and c are the real numbers, a not equal to 0 and b not equal to 0, and x and y are the two variables. Here a and b are the coefficients and c is the constant of the equation. Let us recall through the equation 6x plus 4y equal to 36. The above equation has two variables x and y. Graphically, this equation can be represented by substituting the variables to 0. The value of x when y equal to 0 is 6 into x plus 4 into 0 is equal to 36. By solving the equation, we get x value as 6. And the value of y when x equal to 0 is 6 into 0 plus 4y is equal to 36. By solving the equation, we get y value as 9. Here the points are 6, 0 and 0, 9. This is the graph we get after plotting the points. Pair of linear equations. Two linear equations having two same variables are known as the pair of linear equations in two variables. a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Let us see how we can solve a pair of linear equations by using a graphical method. Graphical method to find the solution of a pair of linear equations. The behavior of the lines of a pair of linear equations in two variables and their existence of solution will be as follows. When two lines intersect each other at only one point, then we can conclude that there is one and only one solution. It means that a unique solution exists for this pair of linear equations in two variables. This type of pair of linear equations is called a consistent pair of linear equations. If the two lines are coincident, we can say that the pair of linear equations will have infinitely many solutions. This type of pair of linear equations can be called as consistent pair of linear equations. If two lines are parallel to each other, which means they do not meet at all, this type of pair of linear equations will be called as inconsistent pair of linear equations. The lines formed by the pair of linear equations and the relationship between coefficients is as follows. We get intersecting lines if a1 by a2 is not equal to b1 by b2. Coincident lines if a1 by a2 is equal to b1 by b2 is equal to c1 by c2. We get parallel lines if a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. Let us consider a pair of linear equations in two variables. Check the relationship between coefficients of x minus 3 equal to 0 and 4x plus 6y minus 24 equal to 0. a1 b1 c1 and a2 b2 c2 denote the coefficient of equation. Consider x minus 3y equal to 0 and 4x plus 6y minus 24 equal to 0. Substitute the coefficient values in a1 by a2, b1 by b2 and c1 by c2. We get 1 by 4 comma minus 3 by 6 comma 0 by minus 24. By comparing the coefficients, we can say that a1 by a2 is not equal to b1 by b2. The equation exactly has one solution. They determine intersecting lines. If we plot the graph for the given equations, we get the following graph. Second condition. Let us consider another pair of linear equations. Check the relationship between coefficients of 3x plus 4y minus 8 equal to 0 and 6x plus 8y minus 16 equal to 0. a1 b1 c1 and a2 b2 c2 denote the coefficient of equation. Consider 3x plus 4y minus 8 equal to 0 and 6x plus 8y minus 16 equal to 0. Substitute the coefficient values in a1 by a2, b1 by b2 and c1 by c2. We get 3 by 6 comma 4 by 8 comma minus 8 by minus 16. By comparing the coefficients, we can say that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. There are coincident lines and has infinitely many solutions. If we plot the graph for the given equation, we get the following graph. Third condition. Let us consider another pair of linear equations in two variables. Check the relationship between coefficients of x plus 3y minus 6 equal to 0 and 3x plus 9y minus 24 equal to 0. a1, b1, c1 and a2, b2, c2 denote the coefficient of equations. Substitute the coefficient values in a1 by a2, b1 by b2 and c1 by c2. We get 1 by 3, 3 by 9, minus 6 by minus 24. By comparing the coefficients, we can say that a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. They represent parallel lines and have no solution. If we plot the graph for the given equation, we get the following graph. Let us see some examples to understand the graphical representation of linear equations of two variables. Example. Check whether the pair of linear equations have no solution, unique solution or infinitely many solutions for the equation 2x plus 5y equal to 20 and 3x plus 6y equal to 12. Solution. Let us consider 2x plus 5y equal to 20 as equation 1 and 3x plus 6y equal to 12 as equation 2. To get the points for the equation 1, substitute the different values of x and y in the equation 1. The table values for equation 1. If we substitute x value as 0 in equation 1, we get y value as 4. If we substitute x value as 10 in equation 1, we get y value as 0. To get points for the equation 2, substitute the different values of x and y in the equation 2. The table values for equation 2. If we substitute x value as 0 in equation 2, we get y value as 2. If we substitute x value as 2 in equation 2, we get y value as 1. After plotting the above points in the graph will be the pair of linear equations has no solution as they are parallel lines. Let us see one more example. Form a linear pair of equations and solve graphically. In class 10, there are 6 students and twice the number of boys added to thrice the number of girls, then the sum is 15. Solution. Let the number of girls be y and number of boys be x. Given x plus y is equal to 6 and consider it as equation 1 and 2x plus 3y equal to 15, consider it as equation 2. To get the points for the equation 1, substitute the different values of x and y in equation 1. Then the table values for equation will be, if we substitute x value as 0 in equation 1, we get y value as 6. If we substitute x value as 1 in equation 1, we get y value as 5. To get points for the equation 2, substitute the different values of x and y in equation 2. Then the table values for equation 2 will be, if we substitute x value as 3 in equation 2, we get y value as 3. After plotting the above points in the graph will be the lines in the graph intersect at only one point. The pair of linear equations have only one solution, that is 3, 3, which is the intersecting point. The solution is consistent and independent. Let us conclude the session by looking into the important points in the session. Points to remember. For intersecting lines, we get unique solution. The condition is a1 by a2 is not equal to b1 by b2. For parallel lines, we get no solution. The condition is a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. For coincident lines, we get infinite number of solutions. The condition is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Thanks for watching.